All right, so this is a key on the worksheet on exponential functions where we're looking at the applications of those exponential functions. And this worksheet is just a basic set of problems, and mostly it's dealing with investments, money, and so forth. All right, now when doing these problems, you're going to need these two formulas. So remember, one deals with compounded interest. That's interest that's being compounded continuously. So remember, this is the one that you're going to use if it uses the word continuously, compounding. And then this one you're going to use when it's being compounded a finite number of times. All right, so that's what you're going to use when you see the words like annually, daily, quarterly, semi-annually, and so on. So monthly, so a finite number of times. So compounding a finite number of times. All right, so let's look at number one. So number one, oh, and by the way, notice what the direction says. For all problems, only round off your answer. Do not round off at any point during that solving process. So make sure when using your calculator, you don't round off until the end. So make sure you know how to use your calculator. All right, so let's look at the first one. All right, so it says if $6,000 is borrowed with an interest rate of 7.4% compounded monthly, okay, what is the total amount of money needed to pay it back in 4 years? And then round to the nearest dollar. All right, so since it's saying it's compounded monthly, so that's a finite number of times, you're going to use this formula. So number one, I'm going to write out this formula. A equals P times 1 plus, oops, let me rewrite it. So number one, A equals P. Remember, the P stands for the principal, the amount you're investing, times 1 plus R divided by N. R is the interest rate. N is the number of times it's being compounded per year. And all that's raised to an exponent. And that exponent is a product of N, the number of times it's being compounded per year, times the time, the number of years. Okay? All right. So let's go ahead and substitute what we know. So in this problem, let me see if I can move it over a little. Uh, okay, so I'm not going to be able to move it over that much to where you wouldn't see it. So I know this though. I know that A is going to equal the principal, which is in this case the amount you borrowed. So 6,000 is the principal, times 1 plus R. Remember R, right? R is the interest rate, and the interest rate must be listed as a decimal. So 7.4%, you move the decimal point 2 places to the left. That's important. So don't put 7.4. You're going to say 0.074 divided by N, which is the number of times it's being compounded per year. So monthly, that's 12 times a year, right? 12 months in a year. So you put 12 here. All raised, and it is important when using a calculator, because that's what you're going to have to do. When using a calculator, to put this product in parentheses. Put this in parentheses. All right, so you're going to say this. You're going to say all raised to the, and then N times T. So N is the number of times being counted per year, times, I'll put a little multiplication symbol here, times the time, and the time is 4 years. All right, so there's your setup. This is the setup. That's the setup you would give me. That's what I have to see. All right, now let's go ahead and use a calculator. So when using a calculator, notice what I'm doing. When using a calculator, I'm going to just write out what I see from left to right. Okay, so watch. So from left to right. So look. So 6,000, see that? 6,000. In parentheses, I'm putting parentheses, 1 plus 0.074, see that? Divide by 12, close the parentheses, right? Now this is an exponent, so I'm going to raise that, so that becomes an exponent now. And in parentheses, you're going to say 12 times 4, close the parentheses, and then press equal. That is what you're supposed to do. So I'm going to show you one more time. So make sure you know how to use your calculator. So remember the directions. Only round off your answer. So if you round off anywhere during the process, your final answer will not necessarily be the exact answer I want because of a rounding error that you made. So always use your calculator. You write out from left to right what you see and only round off at the end. So let's do this again. So you're going to say 6,000, parentheses, so times, parentheses, 1 plus 0.074 divided by 12, close the parentheses, because that's what you see here, but this is an exponent now. So you got to raise what you have now to, see I press this right here, see right here, raised to the, and in parentheses, 12 times 4, and then close the parentheses. This right here is your exponent, because that's what this means. I'm raising it to a power. Press equal, and then that's what you have. Okay, now let's talk about rounding off. So they want you to round off the nearest dollar. So I got to remind you what that means when rounding off to the nearest dollar. So here's what I have. I have 8059.492, right? So when rounding off the nearest dollar, that's at ones place. That's what I mean by the nearest dollar, that ones place. And so you got to look at your tenths place. So this is, see that this is less than 5, right? So since this is less than 5, the 9 stays 9. So the answer is going to be approximately equal to $8,059. So the question is, what is the total amount needed to pay it back? So you're going to have to pay back $8,059. So you borrowed this amount, you have to pay in total this amount. So notice the reason it's larger is because some of this is your interest, right? You have to pay interest. And so you can easily find out your interest. Now you're done with the problem, but you can easily figure out the interest by subtracting 6,000 from the amount you have to pay back. So 8,059 subtract 6,000 gives us that amount, and that's the interest you ended up paying back. All right. So that's number one. So notice your calculator. Use your calculator. Follow directions. Only round off your answer. So if you round off anywhere between here, you're probably not going to get this, and you can lose some points because this is what I need to see. All right, number 2. So number 2, it says Karen takes out a loan. That should be loan, by the way. Sorry about that. Karen takes out a loan of $12,000 with a 3 point, you can see the point, but that's a 3.7% interest rate that is compounded semi-annually. If she pays the loan off in 6 years, how much will she end up paying? And then round to the nearest dollar again. Okay, so let's go ahead and set it up. So notice that the formula, since it's being compounded semi-annually, so that means a finite number of times, the formula is going to be this formula here. You only use this formula if you see the words compounded continuously. All right, so let's go ahead and set it up. So you're going to say A equals the principal, and that is $12,000, just like this, times 1 plus the rate, 3.7%, but you got to change that to a decimal. So I move the decimal point 2 places to the left, so that's 0.037, 0.037, divide by 0.037 divided by n. Now remember, n is the number of times being compounded per year. Semi-annually means 2. So that means 2 times a year, right? 2 times a year. So divide by 2. All raised, and you're going to put that in parentheses because that's your exponent, n times t. N is 2 times, and then the time, oops, sorry, n is 2. Let me rewrite this. N is 2 times the number of years, and the number of years is 6. And then let's use a calculator. So that's your setup. That's what I would have to see. I had to see this. I had to see everything written correctly. And I need to see that exponent in parentheses like this. All right. So So then you're going to say this on your calculator. Now watch how easy it is. Make sure you know how to use your calculator. So you write out, as you go from left to right, you write out what you see. 12,000 times parentheses 1 plus 0.037 divided by 2. Close the parentheses, right? But now remember, this is an exponent, so now let's use the exponent button. So that's this right here. You can't see it. I'm going to raise it up a little. See right here? There's your exponent. And they're going to put that in parentheses. 2 times 6, close the parentheses, and then press equal. And so now what you have is this. So you have 14952.494 and so on. So the nearest dollar means the ones place. Okay, so you have to look at the tens place. This is 5. This is less than 5, so the 2 stays 2. So your answer is going to be approximately equal to 14952. So $14,952. Okay, so how much will you end up paying back? So you borrowed 12,000. You're going to have to end up paying back 14,952. And remember, the reason why it's an increase is because you have to pay interest. So if you subtract 12,000 from this, that gives you the interest you ended up paying. All right, so that was number 2. Not difficult at all, right? Very simple process. All right, number 3, an account earns continuous interest. So notice the word continuous here. Okay, continuous. So for that one, you're going to use the continuous interest formula. So you're going to use this one right here. All right, so an account earns continuous interest. The interest rate is 6.5%. If $3,200 is deposited for 6 years, what is the total accumulated? So how much money will you end up having at the end of that period? And then notice this time it says round to nearest cent this time. All right, so let's go ahead and set it up. I wish I would have had a little bit more room to set it up here. So let me go ahead and see if I can maybe put it here. So you're going to use, remember this formula here, right? P times E to the RT. Now remember, E is an irrational number. That's that number that's approximately equal to 2.718. But on your calculator, there's an E button on your calculator. All right, so the principal is what you ended up in your original amount, the amount you ended up investing, which in this case, you deposited $3,200. So you're going to say 3,200 times E, all raised, and remember the rest of this is an exponent, right? That's an exponent, so put that in parentheses, just like this. And then my interest rate, so remember RT, so R is the rate, T is the time. So my rate is 6.5%, but you got to write that as a decimal, so that's 2 places to the left. So 0.065 times, I'm making the multiplication a little bit larger than the decimal. Can't see that very well, but that's a 5, times the time, which you're told is 6 years. Okay? All right, so now let's use a calculator. So on my calculator, I'm going to say, now let's look carefully. Okay, so you're going to say 3,200 times E. Now to get to E, it's right above the LN button. So that's that blue one right here. So you're going to press second and then LN. Remember, LN stands for natural logarithm. So that's what you see, right? So 3,200 times E, all raised to an exponent. So when you use the irrational number E function, it automatically puts a parentheses for you. So you're going to say 0.065 times 6, and then close the parentheses, and then press equal. Okay, so let's do that again. So you're going to say 3,200. Now to get to my E button, remember that's the one that's that blue part here. That's right above LN. So I'm going to have to get my second function to get to it. So I'm going to press second and then LN. Okay? And then my exponent is going to be 0.065 times 6, close the parentheses, and then press equal. All right, so now we have this. So you want to round off, in this case, to the nearest cent. So let me go ahead and write this out. So to write this out, I have 4726.33854. All All right, nearest cent means the nearest hundredth. Keep that in mind. So the nearest cent, when you talk about the nearest cent in terms of money, that's the hundredths place. So you have to look at the thousandths place. So since this is 5 or bigger, that's an 8. Since this is 5 or bigger, the 3 becomes a 4. And so now you're going to say $4,726 and 34 cents. All right. So that's how you can use a calculator. These are your setups, setup. Then you put all that in your calculator and then round to the place they ask you to. Number 4, determine the amount of interest earned on a $4,500 investment if it is invested at 6.25% annual interest rate compounded continuously for 4 years. And then round your answer to the nearest cent. All right. Now keep in mind this time they're asking for the total interest that you earned. All right, so remember the total interest. Remember, how would you find that? The interest in this case would be the interest you had to pay in number 1. You subtract the original amount from the amount you ended up with. And you're going to see that happen here. But keep in mind, though, it is being compounded continuously, so we're going to use that PERT formula, P-E-R-T. All right, so we're going to use A equals the principal, which is $4,500, times E, and the rest of this is your exponent, so put that in parentheses. You must put that in parentheses. The interest rate is 6.25%. We got to convert that to a decimal, so move the decimal point 2 places to the left. So that's 0.0625 times, I'm making that a little bit larger, the time, which is 4 years. Okay? And so let's use our calculator to figure out what this part is. And we're going to round that to the nearest cent. All right, so we're going to say $4,500 times second, ln, right, to get the E function, and then 0.0625 times 4, close the parentheses, and press equal. All right, now to the nearest, remember it says nearest cent, so the nearest cent, remember you got to look at the nearest cent means round to the hundredths place, so you got to look at the thousandths. Since this is 4, which is less than 5, the 1 stays 1. So this becomes, let's see, 5,778. So $5,778.11, right? Now be careful, that's not the answer. Always remember what your goal is. Your goal here is to find how much interest you earned. So this is the amount you ended up with at the end of 4 years. So to find the interest, so the interest earned equals this amount subtract 4,500, your initial investment. So it'll be 5778.11 subtract 4,500, which equals, so let's do that in a calculator. So 57, that's a 7 right here, not a 28. So 77, so 5778.11. So that amount is your total that you earned, or the total the investment is worth at the end of 4 years. But you want to find out how much interest you earned. So the interest earned will be this subtract what you put in initially, which is $4,500. Oops. Let me go ahead and fix this. So subtract $4,500 equals, and so $1,278.11 is the interest earned. So $1,278.11 is the interest earned. So that would be the answer you would give me. So here's your initial setup, here's your rounding off, and then here is how you figured out how much interest you earned on that account. All right, number 5. So number 5, Sam is saving for a down payment to buy a house. The account earns 9% interest compounded quarterly, and he wants to have $18,000 in 5 years. What must his principal be? So this time it's a little bit, the setup's a little bit different than the others in this aspect. So, so we know that since it's being compounded quarterly, I still have to use this formula right here. So let me go ahead and write that out. So this is number 5. So I know that number 5, I'm going to use this formula, A equals P times 1 plus R over N raised to the NT power, right? Okay, but this time I want to find the principal. So this is what I'm looking for right here. So I have to solve for P at some point, okay? All right, now let's go ahead and substitute what I know, okay? Now listen carefully to what I'm going to do in a little while. All right, so I'm going to substitute what I know. I know that the amount I want to end up with at the end of so many years is $18,000. So $18,000 is A equals P, which is what I'm trying to find, times 1 plus R, which is 9%, so 0.09, divided by N. N is the number of times being compounded per year. So quarterly means 4 times a year, so it'll be 4 down here, all raised to the exponent, which is 4 times t, and t is, the number of years is 5. Now here's the way I would do this, okay, so listen carefully. All right, now what I would do first, because you remember you want to round off at the end, always round off at the end. What I would do first is this. I would figure out if this right here is a rational number, okay? And so notice 0.09 divided by 4, that's a rational number. So this is always going to be a rational number. So what I would do is this. I would put this in my calculator first. So that's the way I would do this. I would say 1.09 divided by, 1 plus 0.09. Let me erase all that. So 1 plus 0.09 divided by 4. And you get this, okay? So it's a terminating decimal. So let's put that in the calculator. I'm sorry, let's put that here. So 18,000 equals P times 1.0225. And that's all being raised. And then 4 times 5 is 20. So let's go ahead and put a 20 up here because that's easy to do, right? 4 times 5 is 20. All right, now what I want to do is I want to figure out if this amount raised to the 20th power is too many digits, is what I'm asking. Is that too many digits to write out? So let's see. So this right here, raised to the 20th power, and that's too many digits because because remember, it could go 1, right? So it could go 1. So what I would do is this then, listen carefully. All right, so what I would do is I would go ahead and write this part as a decimal like I did here, and then multiply this out. 4 times t or n times t, and put that here, and then let's go ahead and solve for p. So what's going to happen? All right, so 1.0225 raised to the 20th power. So to get p by itself, I'm going to divide both sides by this number right here. 1.0225 raised to the 20th power. Okay? 1.0225 raised to the 20th power. And then this is 1. So I get p is going to equal this. So p is going to equal 18,000 divided by 1.0225 raised to the 20th power. So we're doing all that because the direction says only round off at the end. All right, so here's what you're going to do. All right, so listen carefully. The rest of this is simple. You're just going to write out what you put in your calculator or what you see. So 18,000 divided by, in parentheses, let's put parentheses since I have parentheses there, 1.0225, close the parentheses, and that's being raised to the 20th power, so raised to the 20th power, and then press equal, and that's what you get. So this is approximately equal to, and I think they said round nearest cent. All right, so the nearest cent, remember how we did this. So the nearest cent means the hundredths place, so that's a 9. You got to look at the thousands place. Since this is 5 or bigger, that's a 6. The 9 becomes a 10. All right, so let me go ahead and remind you how to deal with that. So So you have 11534.696. All right, so since this is 5 or bigger, the 9 becomes a 10, right? So this is really 70. So you get 11534.70. All right, so this is approximately equal to $11,534.70. Okay, so that is the principal to the nearest cent that you would have to initially. Let's see. So that would be your original down payment. So your down payment would have to be this amount. So that's your down payment. Okay. All right. So remember our process, how we did this. Well, make sure you do it like this so you don't mess up. Okay, because you don't want to round off anywhere along this process. You want to round off only at the end. All right, so notice the process I went through. Okay, so we'll put this and put on extra page. All right, let's look at number 6. So number 6. So Maria is saving for a down payment to buy a new car. So it'll look just like number 5. So we're going to do another one like number 5. The account earns 5% interest compounded semi-annually. She wants to have $8,000 in 6 years. What must her principal be? Okay, and then you want to round to nearest cent. So we're going to do number 6. It'll look just like number 5. So let's remind ourselves how we can do this. So A equals the principal times 1 plus R divided by N, all raised to the NT. Okay. All right, so you're looking for the principal. That's what you're looking for. So the amount you initially, let's see. So she wants to have $8,000 in 6 years. So 8,000 is your amount. So 8,000. P is the initial down payment, which is what you're trying to find, times 1 plus the rate. The rate is 5%, right? So 0.05 divided by N, which is number of times per year. The number of times per year is semi-annually, so the N is 2. All raised to the 2 times T, and time is 6 years. All right, now notice all these are rational numbers. So this is going to be a rational number right here. It's not irrational. So let's go put that in your calculator then, just like we did the previous one. So let's put this in your calculator. 1 plus 0.05 divided by 2, and then press equal. So I would put 1.025 here. So that's what this is. So I get 8,000 equals P times 1.025, and then 2 times 6 is 12. Okay? And now we're going to solve for P. So let me go ahead and rewrite this over just to remind you how to solve for P. 1.025 raised to the 12th power. So to solve for P right now, I'm multiplying P by this number, right? So to solve for P, since I'm multiplying by this number, I'm going to go ahead and divide by that coefficient. I'm going to do that to both sides, though. 1.025 to the 12th power. So this number divided by itself is 1. 1 times P is P. So let me write it like this. So P is going to equal this number right here. So P is going to equal 8,000 divided by 1.025 raised to the 12th power. And the rest is just your calculator. So watch how easy it is to put in your calculator. So your calculator is 8,000. On your calculator, you're going to put 8,000, which is the numerator, divided by, in parentheses, 1.025. Close the parentheses. I'm going to raise this part here to the 12th power. So raise to the 12th power, press equal, and that's what you get. All right, so to the nearest cent, so that's the hundredths place. Since this is 5 or bigger, which is a 7 in this case, the 4 becomes a 5. So to the nearest cent, so that's approximately equal to $5,948.45. So that would be the down payment that she would need to have. So the down payment. Okay, so that would be the down payment. All right, so that's number 6. So it's not that bad, right? So it's not a difficult process, but notice the steps you have to go through when using a calculator. So we've got to solve for P first with these. and then put this part here, and this part here into the calculator. All right, let's do number 7. So number 7, the very last one now. So number 7, we have, I don't know why I keep saying load. We have a loan. A loan is paid off in 13 years with a total of $162,000. The loan had a 5% interest rate compounded quarterly. What was the principal? So number 7 is just like numbers 5 and 6. So was the principal, and around this time, you want to round to the nearest dollar. All right, so number 7. Actually, I can put this here. I have enough room to put that there. So number 7, you have, oops, no, I can go ahead and write it out. So I'm going to use this formula, A equals P times 1 plus R divided by N raised to the NT. So A is what you ended up with, which is $162,000, right? Equals the principal, which is what you're trying to find, times 1 plus the rate, which is 0.05, divided by N, which is the number of times being compounded per year, which is quarterly, so that's 4. All raised to the NT power, so that's 4 times the time, and the time here is 13. Okay, and so this becomes 162,000 equals P times, now let's put this part in the calculator. So in the calculator, we have, let me go ahead and put that here. So in the calculator, we have, for this part here, that's a rational number, so we can put that in the calculator very easily. 1 plus 0.05 divided by 4. So we get this terminating decimal. That's a rational number, terminating decimal. So it becomes 1.0125, all raised to this exponent. So 4 times 13 gives us 52. All right, and then to get P by itself, you can divide this by this number here. So P then will be $162,000 divided by this number, 1.0125, all raised to the 52nd power. And now let's go ahead and round this off to the nearest dollar. Nearest dollar. All right, so on your calculator, I'm about to do that. You're going to say the numerator, just like this, divided by, in parentheses, 1.0125, close the parentheses, and this number right here, which is this, has to be raised to this exponent. So I'm going to press the exponent button, and then the number 52, and then press equal, and that's what we get. All right, remember the nearest dollar, just like in some of the other problems, means the nearest 1. There's a ones place. So that's that ones digit. So I got to look at the tens place. Since that's an 8, that's 5 or bigger, the 2 becomes a 3. So the answer is going to be $84,913. All right, so $84,913. So so the principal, this right here, is your principal. That was the original amount invested. Okay. All right, we invested. Not in this case, it was a loan. So that was the principal of the original amount that was borrowed, I guess. So the original amount borrowed. All right. So that is the application part of the exponential functions. So make sure you look at the difference between 1 and 4. So 1 and 4 versus 5 and 7. All right. So remember, 5 and 7 is where you actually had to find P. In the other problems, you had to